Welcome! In this video we will continue to look at the graphics control and the use of masks to create hexagonal maps with the PowerBasic Windows Compiler. This is where we left our program in the last video. We have a randomly generated hexagonal map on which there are terrain types actually shown on the letters between A, B, C, D and E. If you click on any individual hex, in the status bar we're displaying which hex location you clicked on, for example F3, and the terrain type underneath the hex. What we're going to do today is we're going to add another terrain type, and we're going to randomly select a location to be marked as a pickup point. So the first thing to do is to add our new graphics. So first we'll bring in our new terrain type, which we'll mark as F, and we'll also bring in two additional bitmaps which are going to be used to mark the pickup point, the extraction point on our map. So let's have a look at the code. We're going to add a little to the beginning of our program so that we can actually define the names of terrain types in code rather than having to refer to the numbers like 65 and 66 all the time. So we're going to use an enumeration here called terrain, and the elements of this are going to be the name of the type of terrain. We'll set the first one as 65, being grasslands. Doing it this way, the first element, grasslands, will be equal to 65, and then it'll be 66, 67, 68, 69 and 70. So what we want to do now is we want to search for anything which is 65, and we can replace that with this. Makes it much more readable. And we may have to search for 64 because we did have some references to 64 in the code. That should be us. And the other thing we're going to do is we're going to put in another type so we can store our pickup location. So having set that up, we'll just try a quick test compile to make sure we're okay. And obviously we need to put a percentage in front of that. And it'll be exactly the same with this one. And with this one as well. And our program runs quite healthily. So if we have a look at our event handler, the callback function itself, in here, just to reiterate what we're doing, we are attaching the graphics control, marking it as redraw, which means it will not redraw the graphics control automatically until we actually use the redraw command. We're making the background black, and we're building our graphics map. Now the other thing I want to do today is in the graphics map we're actually setting up the random terrain. We may wish to redraw the graphics map at some point during the program, but we don't want to regenerate the map. So we're going to put in a separate routine just to generate the random terrain. And we will use the randomize command with the timer option to make sure the seed for the random number generator is as unique as possible. And then all we're going to do is a for next loop for our global terrain array to set the terrain type. Now we want in here this terrain to be a random number, so we want a random number between the grasslands, and the final in, which will be water. Now, having got that type of terrain, we wish to store it in our global array. Now, we know we're storing it in the 0 element, but what I want to do, rather than having to refer to elements all the time, is we will set some constants up to make this a little easier. So we'll let terrain 0, we'll set x equals 1, and we'll set y equals 2. That way we can refer to them much easier in code. So in here, rather than saying 0 all the time, we'll mark it as terrain. So we want that to be equal to the terrain number we have just generated. And this routine will quite happily run through the entire array and generate random terrain. So if we go back to our callback function, our event handler, we can see we're building the terrain, then we're building the graphics map. Now if we do a quick test of that to make sure it generates, and there we have our random map. So back to the event handler. The next thing we want to do is we want to decide on the pickup point, where the extraction point for our troops is going to be. So we'll create a new function just to do that. I'll pass it in the handle of the dialog we're on. Our initial call to the setup pickup function will determine where the pickup is actually going to be located. We may want to redraw this icon we're about to put onto the screen at some point later, so we're going to pass it a true or a false. True to mean we want the pickup point regenerated, false to mean we just want the icon put on screen. So let's have a look at creating our new function to do that. And we'll define our variables. And we'll call this one redo. Now we may not want to have our pickup point being just any location on the map. There may be some locations which are not ideal, for example, water. So what we're going to do, we're going to look for a terrain type that is equal to grasslands, on the assumption that at least one of the hexes is actually grasslands. So we'll need some variables in this one. We'll need to do a test on the long redo to see whether we need to actually regenerate it or not. And we can use the isTrue function for that one. So we'll do that logic first. And we'll do a loop. We'll do a do loop while the long found is equal to false. Now we've just initialized it, so it would be initially false. Now we're going to use our random number generators again. What these are doing is they're going to give us a number back for the maximum number in the x coordinate and a maximum number on the y coordinate, and we're putting that value into these two variables, long r and long c. And then all we have to do is to test the terrain type. Within this loop, we're working out the x and y coordinates. We're checking the terrain location to see if it's actually going to be valid. So after we come out of this loop, we can then store our pickup location. I'm using the prefix command here to save a wee bit of typing. So if we're not regenerating the pickup location, we need to populate the long R and the long C to be equal to the value that's already stored in that location. being the x and the y coordinates that are stored in that type. So by the time we come out of this routine, we'll know exactly where we are. Now all we have to do is the same routine we did in our previous video to actually pick up the mask. So first thing to do is to pick up the bitmap mask for pickup mask. Now we're going to need some more variables here. These are the variables we're using for handling bitmaps. So having got the location of the file we want to load, we'll then put in a routine to actually open up the bit mask and read the width and the height of the bit mask. Now we could hard code these all the way through the program, but it's easier actually to be flexible and take it from the size of the bitmap. That way if you do actually change the size of the bitmap at some point later, you don't have to change a lot of code. And we'll also pick up the name of the pickup bitmap. This is the one that's going to be placed on top of the mask. With the same logic we had before, we're going to generate the locations of the x and y start from the data that's stored within the terrain array. Now that's storing, as you'll remember, the central location of the hex. So we're basically subtracting from that the width of our bitmap divided by 2, so we get the top left hand corner. And having got that, we then paste in the same 2 lines of code we've been using to actually put our mask in first and then merge in the bitmap on top of it using the graphic copy command. Now having done all that, the only thing we need to do is to close off our bitmap, and then we will redraw the graphics control. So we have a look through that. We've got a setup pickup function which is taking 2 variables, the dialog handle and the redo parameter. The redo parameter we're using to see if redo is true, then we are regenerating the pickup point using a couple of random number generator calls. And we are looking specifically for terrain that matches this. Having found that terrain, we'll then store the location, and we will then pick up the details of the mask and the bitmap we want to put on top, and we'll call it. Now if we go back to our event handler, we'll see in there we're working at the pickup point and we should be putting it onto the screen. So if we try a compile on that, which is clean, and we run our program now, and there is our pickup location shown on screen, in this case L1. Well, that's ideal. What we want to do now is we want to indicate to the user perhaps by animating this pickup location icon. So how can we actually do that? Well, one approach would be to use a timer on our event handler. So let's go back to the event handler and we will create a couple of new variables to handle a timer. One for the timer itself and a count variable to be used to keep track of how many times we've actually called it. So we will create a new case statement in here for our timer. Now, in order to call our timer, we'll have to initialize it. And we're going to set this one to trigger every 500 milliseconds. Set timer is a Windows API call. And we'll put in our parameters. There's our 500 milliseconds. So that line of code will actually trigger an event every 500 milliseconds for timer number 1. So in here we're going to advance our timer. First thing to do is to increment the count variable. we may not wish this flashing all the time, just long enough for the user to notice where the pickup point is. Now we've already placed a mask on the screen which indicates the pickup point, the round circle. What we basically want to do every 500 milliseconds, every half a second, is to replace the hex bitmap and then another 500 milliseconds put the red circle back on top. So we just use the mod command to work that one out. So if it's divisible by 2 with no remainder, then it's every alternate one. And we're calling the same set pickup routine, but we're using false this time because we don't want it to regenerate the location of the pickup, just to redraw the icon. And in the other half, we want to put the train back. And we'll create a new function to perform this because we'll probably be doing a fair bit of redrawing terrain at some point. And we'll be passing it the information for the X and Y locations of the pickup point, which was stored in our type. So we need a new function to perform this. And I'll turn these into straightforward X and Y coordinates. Now we're going to need many of the variables we used before, so we'll just paste them all in. We need to know the terrain type, we need to know the bitmap and its mask, we need to know its width and height, and we need handles for the bitmap, bitmap mask, and the location onto which we're going to be pasting. All the same as we've done several times before. So the first thing to do is to determine the terrain. Now we know the terrain is actually embedded in our global array. So this will tell us the code for that. And we want our long X start and long Y start, which is the location on screen to which we're going to be drawing. And we know it's also in our global array. As and so. Now remember, this is the center of the hex. We'll need to offset this. Then we'll do the same as we've usually done to pull in the hex mask. So we set the name of the bitmap mask and we'll load it up to actually find out what the width and height are. And just as we've done before, I want to pull in the actual bitmap, which is going to be merged in with the mask. So there's our bitmap, as in the train which we've just picked up. So we now have the name of the bitmap. We can then load up the bitmap mask, get back the handle to the bitmap mask, load up the bitmap itself and get back the handle to that as well. So the only thing we have to do now is we have to get the offsets for where to actually place the bitmap on screen. Now we know this is the center of the hex, so we want to actually take the width and do an integer division by 2 so we can work out the top left hand corner. So we'll do that both for the X and the Y coordinates. And now we have the location to where we can copy the graphic. And again, this is the same piece of code we've done several times before. We use the graphics copy command using the bitmap handle for the mask, the location on screen we want to put it, and using the mix mask source to copy it in. And then we're going to merge in on top of that using the handle we've got for the actual bitmap. So if we go back to our event handler and just run through what we're doing, We're attaching the graphic, we're clearing it, making a black background, we're generating some random terrain, storing that in our global array, we're building the graphics map, we're setting the pickup location by placing the circular target over the location we're going to be picking up from. We're then setting a timer going, and every 500 milliseconds this timer is going to kick in, and every alternate go it's actually going to first of all display the pickup location and then redraw the hex. Quick compile to see if we've got that clear. Oh, we missed the return from that variable. And there we have it flashing. Now you notice there is a small problem with this one in that the red circle actually goes slightly beyond the bounds of the hex bitmap. So it's actually encroaching in on the hexagonals around the central hex. So our method for actually doing this animation is falling short. Now, ideally we want to possibly copy the entire graphics background and put it entirely back at one go. If only there were an easy way of doing that. Strangely, there is. We go back to our event handler. What we're doing in here needs to be changed slightly. Now we won't get rid of this redraw hex terrain, we may need that later. What we're going to do is we're going to store the entire contents of the graphics bitmap. So up here, before we actually call the set pickup, at this point in the code, the graphics map is the pure hex map with nothing on it. So what we want to do here is to store the whole of the graphics control. And you can do this in one line of code. Graphic get bits will actually take everything that's on the graphics control and store it in a string variable. So we will create this string variable as a global, and we'll put this at the top of our code. And if we go back to our event handler, so we're storing the graphics bitmap before the set pickup is there, and rather than redrawing it, we're going to be using a very simple one line of code to put it back. Graphics set bits, and then the name of the global variable. Now because we've got the redraw option on, we will want to use the graphic redraw to tell the program to redraw the graphics. So if we try that now, we will see that it is actually successfully flashing the red circle and then redisplaying the entire graphics map of each goal. Now, having done all that, we'll probably want to actually reset the pickup location so the user can actually see it. But what we'll do in our timer, when the timer actually gets killed, now we haven't actually killed off the timer here, so we should really do that. In here we will put a kill command to kill off the timer. Again, this is under a Windows API call. And we will follow that with the setting up of the pickup icon in there. So if we run that one now, so the pickup location is now animated on screen, and once the timer runs out, the pickup location is still circled. Now we can use this technique to store the graphics background, place a bitmap on the screen, redraw the background, move the bitmap, redraw the background, and effectively that approach can be used to animate something moving across the screen. But we'll cover that in a later video. That's it for today. Thank you for watching.